Hi Ramesh. Ramesh, you can start with the session now. Ramesh, you can unmute yourself and you can share your screen.
Hello, can you hear me now?
Yeah, now it's audible.
Yeah, sorry, my mistake. Actually, there is a loose contact here. Okay, fine. So, are you able to see my screen, guys?
Yes, we can.
Yeah. Okay, sure. Today we are going to discuss about Juniper architecture and what are the control plane functions and forward plane functions in Juniper. Okay. So, this is Junos voice fundamentals. So we'll discuss about software architecture and control plane and forwarding planes and routing engine and packet forward engine and what is the transit traffic and exception traffic. After that, we will try to do lab. So how to assign IP addresses on interfaces. What are the CLI modes? So we'll start doing lab. Okay. Fine. So before going to do that, so in Juniper, you will have several platforms like routing devices. We have routing devices and we have security devices and switching devices. Okay. So these are the routers. In the routing platform, you will see all these MX series routers and MT and ACX series routers. So basically, these are the core routers which we are using in a service provider environment. So these are the Juniper MX series routers. So these are the models, and these are the Juniper EX switches. Okay, so we will use these switches in enterprise network as well as data center. So based on your requirement. So these are the models in EX series. So EX4600, EX4300, 3400, and EX2300. So there are several EX switch series are there. So I just taken some of few. So these are the QFX switches. So you have two types of switches in Juniper. One is uh, EX series and QFX series. So these switches they will use in data center actually. So these switches can support huge throughput. So these switches will have 100G of interfaces, and they will install in data centers to process the packets with 100 Gbps speed. So these are the SRX firewalls. Okay, these are the security devices. So you can see here on the slide. Yeah. So before going to start, what are the hardware components we will see in Juniper? Okay, this is MX960 router. Okay, if you see here, right? So here these are routing engines. You will see routing engines and line cards and switch control board and power modules and fan tray. These are the main hardware components for each and every Juniper hardware. One is routing engine, one is packet forward engine. So these packet forward engine are located in MPC or DPCs. So routing engine and FPCs and switch control boards and mix and picks, power modules and fan trays. These are the hardware components. Here you can see on the image, right? So here these are the routing engines. Okay, top of that you can see switch control board. So basically switch control board, routing engine, it houses the routing engine. Switch control boards are houses the routing engine. Actually, we have to insert the routing engine inside the switch control board. So if you buy any product, right, you have to install the line cards. Okay, so one moment. Okay, so these are the switch control boards. Two switch control boards we have here. So first you have to install switch control boards. Inside that you have to install routing engine. Okay, so switch control board provides the throughput. Okay, what are the connections between line cards and routing engine, everything will going through switch control board only. Okay, so these are all are connected to the mid plane. All line cards are connected to the mid plane of this chassis. Okay, first you have to install switch control board. After that you have to install routing engine. So in routing engine, where you have to install Junos image. So you have to install Junos image on routing engine. So all the control plane functions are handled by this routing engine. Okay, after that these are the line cards. In traditionally in Juniper terms, we used to call FPC slots. Okay, here you can see all FPC slots. This is MX960 chassis. You will see 12 slots here. So two are routing engine slots and SCB slots, and other 10 are line cards. Okay. So in we used to call this slots or FPC slots. Okay, FPC slots. So we will have different types of FPCs, MPC and DPCs. This we used to call FPC, types of FPC, MPC or DPC. DPCs are legacy line cards. Nowadays, they are using MPC line cards. Okay. So these all are FPC slots. In these FPC slots, we have to install either MPC or DPC according to your requirement. Okay. In this MPC also, we will have mix, modular interface cards. So some in the at the end sides you need optical connections or Ethernet connections or 100G connections or 10G connections. So based on your requirement, the type of MIC card you can install on MPC card. So you can see here, right? This is MIC card. So MIC cards are, you can these are hot swappable. You can replace it, and you can in case anything wrong with this MIC card, you can replace the MIC card. This is not inbuilt. Okay. So these are the hardware components actually. So routing engine, SCB, and FPC slots, we will install MPC or DPC line cards. So this packet forward engine is located in MPC or DPC. Again, in MPC, according to your requirement, you will install MIC cards, modular interface cards. Okay. So I'll show you next. So in between, if you have any queries, you can ask. Okay. So these are the MIC cards. See, one MIC card have Ethernet ports. This will have satellite ports, and this will have SFP ports, 10G or 100G. These are serial ports. Okay. According to your requirement, you can install the MIC cards on MPC card. This is the MPC card. Okay. And this is a switch control board. You can see, right? So this is the empty slot. We haven't installed any routing engine here. This is the empty panel. Okay. You can remove these screws and you can install the routing engine, and entire this card you can install on the chassis here. Okay. These are the hardware components. Okay. Each and every hardware component have their own responsibility. That's why I'm explaining about hardware components. Okay. So routing engine will handle control plane functions, and this packet forward engine, it is located in MPC or DPC, which handles the forwarding plane. Okay. This MPC or DPC cards will handle the forwarding plane functions. Okay. So these are the MIC cards, and this is a switch control board. Okay. So this is the architecture. Okay. So you can see control plane functions. So Juniper architecture will separate both control plane and data plane functions. Okay. And if you see control plane, right? So the control plane functions are handled by this routing engine. If you see here, right, routing engine. So in the routing engine, you will have different daemons. Okay. This is Unix based, architecture. So similarly, you will have daemons for different processes. Okay. For management process, you will have MGD. For routing protocol, you have RPD, DCD for interface configurations. Okay. And this is for chassis. Okay. All these daemons are located in routing engine. Okay. If you configure any routing protocol, right, it will run the algorithm, and it will build the routing table. Also, all the best path will be populated in forwarding table. So what it will do, it will send one copy of forwarding table to the packet forward engine. So it will send the one copy of forwarding table to the, all the best paths are populated in forwarding table, right? So it will send the one copy of forwarding table to the forwarding packet forward engine. Where this PFE is located? PFE is located in MPC or DPCs. Okay. So this is data plane. So whatever the traffic which is pointed to the the some not to my device. Okay. So the transit traffic, you can say. So transit traffic is performed at PFE level only. It will not come to the routing engine. So there is no burden on routing engine. So this is the advantage in Juniper architecture. So whatever the transit traffic, right? So which is performed at PFE level only. Suppose this is MPC cards, right? Here you will see PFEs. So you will have one forwarding table here, copy of forwarding table, right? So one forwarding table, it will send to the each PFE. So these are the line cards. In each line cards you will have PFE. So this forwarding table will be located in all line cards, okay, wherever the PFE is located, right? So it will send to all PFEs. One copy of forwarding table, it will send to all PFEs. So if you have connections, right, here you connected one site, some router. So again, this router to you have connected another router, this interface to you have connected another router. Okay, so the packet is not destined to this router, it is destined to this R3 something. This is R3, you have to call, okay, you can take R3, this is R1. So I'm trying to reach from R1 to R3, this is R2. Okay, so the packet will hit on this line card, MPC card, and it will not send to the routing engine. Okay, it will the packet processing, the routing lookup will perform at here only, the PFE level, and will do route lookup at forwarding table, and will send this packet towards this line card to the R3. Okay, this is transit traffic. So due to this, there is no burden on routing engine. So because of this, we can say, the CPU process is also stable for transit traffic. So other architecture like Cisco, other architectures, right? They will run the device with software only. So control plane and forwarding plane both are in work based on the software. So here you can see CPU load is for transit traffic. There is no CPU load on routing engine compared to other vendors. Okay, so this is architecture. You can see this Junos, Juniper will separate both control plane as well as the data plane. So control plane is handled by the routing engine and the data plane is handled by the PFE. These PFEs are located in line cards, MPC or TPC line cards. Again, in MPC line cards, we have types of MPC line cards: first generation, second generation, up to 10. MPC 1 to MPC 10. We will have models in MPC cards. Okay. So this is the control plane. So as I said earlier, the control plane is handled by the routing engine. The control plane runs on the routing engine. Its roles is to manage and control the behavior of the device, including data plane as well as the service plane. Okay, this is this operating. We have to install Junos image on routing engine only. So this software was built with FreeBSD Unix operating system. So it uses the FreeBSD Unix architecture. So you will see the similarities of the Unix in Junos. So these are the components. As I said earlier, you will see different daemons. RPD, routing protocol daemon. This is device control daemon, and MGD. For management, we have separate daemon, and this is chassis D, and this is PFED. Okay, so routing daemon is, it deals with all routing protocols and routing functions, routing table updates. Everything is handled by this processor, this process, routing protocol daemon process. Okay, whatever the interfaces, if you configure any IP addresses on the interfaces, right? So all this interface configuration, everything will be handled by this DCD, device control daemon. Both physical and logical properties. So physical is physical interfaces, logical in the sense this loopback interfaces. Whatever the configuration you have done on interfaces, right? This will be controlled by this DCD daemon, and this is management daemon. So if you want to take CLI through SSH or console, right? This CLI is provided by the MGD daemon. This all CLI process was handled by this MGD daemon, management daemon. Okay, this is chassis daemon. So as I said earlier, in chassis you will have hardware components: routing engine, switch control board, MPCs, DPCs, mix card, fan trace, and power modules. All these are hardware equipment in the chassis. So if anything goes wrong with this hardware, right, so it will generate an alarm. Okay, this chassis D is responsible to monitor and handle this all line cards, all these FRUs we used to call field replaceable units. Okay, yeah, and the PFED. So the packet forward engine daemon process controls the communication between the PFE as well as routing engine. I said, right, as I said earlier, it will send one copy of forwarding table to the forwarding engine, right? This is the communication. Both are exchange. I mean, routing engine is sending one forwarding table to the packet forward engine, right? So this communication is handled by this PFE, packet forward engine daemon. So here, if anything wrong, anything happened with the DCD process, right? So other process will not affect. Other process will continue to work. So due to this, you will not observe any outage or any service impact. Okay, that is advantage here. So these are the PFE components. So we will have FPC cards, right? MPC or DPC. So in MPC cards, we will have types of MPC cards: first generation and generation 1.5 and second generation and third generation. So MPC type 1 to type 2. Okay, MPC type 1, type 2 or belongs to generation 1, and MPC type 2, type 3, type 4, okay, belongs to generation 1.5, and MPC type 5, 6, 7 belongs to generation 2. Above 7 all belongs to generation 3. So each generation, the throughput is increasing. Okay, the line card which is handled, right, the throughput, the speed, it is increasing at each generation. So on first generation, you will see this ASICs. These are the ASICs. This is input output chipset. These are the memory chipset. This is lookup chipset, and this is COS, quality of service functions, which is handled by this chipset. These are the application specific integrated circuits which will be there in line cards. You can see on these line cards. Okay, these are the chipsets you will see on first generation line cards. These are the chipsets you will see on second gen 1.5 generation line cards, and these are the chipsets you will see on second generation. And third generation you will see Eagle chipset. This is Eagle chipset. Okay, you will see only one chipset, okay, which handles 480 gigabit per second throughput. This is all about hardware. Okay, sorry, I don't understand Hindi. So Ahmad Babar, you're saying something? Hello.
जी नहीं सर कुछ नहीं बस
Okay, so okay, if you have any queries, you can ask me anytime. Okay, you can stop me and ask me. Okay, fine. Okay, yeah. So two things are very important. One is transit traffic, one is exception traffic. Okay, so the transit traffic, if you see in this diagram, right, this is the computer and this is the server. I want to access this IP address. I want to access this server 1.23. Okay, these are the Juniper routers. Okay, router 1, router 2, router 3. So this router 1 is connected to the PC. Okay, if I'm trying to access this server, the packet will arrive at this R1. Okay, R1, what it will do, it will do the route lookup. So in the IP header, it will check the destination IP address is 1.3. So it is destination address is 1.3, which is not pointing to me. So it will check the routing table and forward the packet to R2. Okay, so R1 perspective, this traffic, 1.23 destination traffic is a transit traffic, which is not coming to me, which is pointing to someone 1.3, 1.23. It is not pointing to me. So what it will do, it will check the forwarding table. Okay, it will forward the traffic to R2. Similarly, R2 will do route lookup and forward the traffic to R3, and R3 also will do route lookup and forward the traffic to the server, respective server. So this R1, R2, R3 perspective. So this is transit traffic. Okay, that the packet which is coming to me, right, that is exception traffic. However, the packet is which is not coming to me, which is destined to someone, either server or some other router. Okay, which is destined to 1.23, which is not assigned any this IP address is not assigned to any of interfaces. Okay, so it will forward the packet to the next router. So that is called transit traffic. Okay, the exception traffic is like the traffic which is destined to me. So this is R1. Okay, so if you see, right, if you want to access the R1, okay, so suppose this is same 10.10.10.0.10.10 IP address, and this is something 10.10.10.0.10.11. Okay, if you try to ping right from PC to router, so the packet arrives at R1. Okay, so it will check the destination IP address is 10.0.10.11. Okay, this IP address is assigned to me, assigned one of the interfaces of this router. Okay, this packet is destined for me. Okay, so what it will do, it will send to the routing engine for the packet process. Okay, so initially the packet arrives on line card. Okay, the packet is initially the packet arrives on this interface, one of the interface. Okay, it will check the destination IP address. Okay, this destination IP address is pointing to me. What will it do, it will send the packet to the routing engine for further processing. Okay, internally it will send to the routing engine. So that is called exception traffic. Okay, the traffic which is destined to the RE, and RE CPU performs the route processing, as simple as that. Okay, this all about, you know, Junos fundamentals. Okay, what are the what types of devices we have? For routers, we have MX series and ACX series, M and T series, and for security we have SRX firewalls, and switching. Switching devices are EX and QFX. Okay, these are the hardware devices we will support. Okay, this is the architecture which is common on each and every platform. Okay, so far if you have any queries, you can ask me.
Can you explain the transit traffic again, once again?
Okay, so if you see here, right, okay, this is a PC which is connected to the R1. Okay, this is R1, and this is R2, and this is R3. Okay, so you're trying to reach this server 1.23. Okay, so in between, from computer to server, in between you will have 3 nodes, R1, R2, R3. Okay, both are connected each other. So if you initiate a ping from PC1, okay, the ICMP packet, the whatever the packet, right, the packet will arrive on R1. So R1, what it will do, it will do the route lookup, right? So the destination IP address is 1.23. It will do the route lookup, and it will check the forwarding table, and this IP address 1.23 is not destined to me. It means not pointing to me. This is not in my routing table. Okay, yeah, it is pointing to some other devices. So it will check the forwarding table and find the exit path, and it will forward the packet to the R2. Okay,
So it is not forwarding to the routing engine then.
no, yes, it will not forwarding to the routing engine. The route lookup will done on PFE only.
Okay. So can you just show? Can you explain it in terms of that hardware, card, line card?
Yeah, I'll
Yeah,
do that.
this one.
Yeah, this one, right?
Yeah.
So initially, suppose this is interface 1/1/1, just for example, GE 1/1/1. So which is connected to the PC here. Okay, so if you initiate a ping, right, the packet arrives at here. Okay, here this is a MPC line card, right? This is MPC line card. I told each and every line card you will have packet forward engine. Okay, so what routing engine will do, it will send one copy of forwarding table to the packet forward engine. Okay, in this line card you will have table, forwarding table. Okay, all the forwarding table, whatever the forwarding table it is present on routing engine, the same forwarding table will be there in packet forward engine. Okay, the packet is arrives on this MPC interface. Okay, this interface, and it will do the route lookup, that 1.23, the destination. So it will check the destination IP address, and it will find, okay, this is not pointing to me. So in the forwarding table you will identify the exit interface. Okay, this is not pointing to my router, it is pointing to the another router. So it will forward the packet. So in the forwarding table you will have the exit interface to reach the destination. Suppose this is a exit interface, suppose for example, so it is connected to the another router. Okay, so at PFE only, you know, at PFE level only it will perform the packet processing. It will send to the another router. It will not send to the routing engine. Okay. In case if the packet is pointing to this routing engine, right? So it will identify this IP belongs to my router and I need to process. So what PFE it will do? It will send this packet to the routing engine for further processing. So these are internally connected to the mid plane. So you will have chipsets internally. Okay. So as I said right here, you will see chipsets, lookup chipset right here. So this lookup chipset will be there in PFE. So this is lookup chipset is responsible to do lookups, forwarding lookups. Okay. It will send to it will send to the routing engine. It will do the lookup forward. It will do the routing lookup here, and it will forward the packet to the routing engine. If the packet is destined to the router, if this packet is destined to the another router, right? So it will find the exiting interface in forwarding table and it forward the packet to the next router. That is called transit traffic. Simple. If the traffic is handled by the routing engine, right? Whatever the incoming traffic is, which is handled by the routing engine, right? That is called exception traffic. So in other vendors, whatever the traffic, everything it will go to the route, routing engine. In other vendors, they used to call CPMs and RSPs. Okay, so those architecture is like based on software. So the forwarding plane and control plane both work based on the software. So here it is dividing. Okay, because of this we will have advantage. So there is no workload on CPU. If you perform the transit traffic at PFE level, right, it will not go to the routing engine. Simply it will perform the packet process at PFE level and it will forward the traffic to the next router. Yeah.
So this routing engine, so that is actually a separate hardware.
Yes, this is separate hardware. Routing engine is a separate hardware. See, you can see here, right? I have
Right,
mentioned here.
yeah.
Here you will see this is the routing engine.
And
Okay.
what was that SCB?
Switch control board. Okay, it provides the switch fabric. So the communication between the routing engine and the line cards is happened through switch control board. Okay, it provides the 24 port Ethernet switch, logical switch. Internally, you have threads. Okay, here it is kind of a 24 port switch. This line card 1, right? This is 0, 0, 1, 2. Okay, so FPC 0 is connected to here SCB 0 Ethernet switch internally. This is a port. These are the ports which is provided by the SCBs. Okay, whatever this is FPC slot 0. If you install any line card on FPC 0, right, it is connected here. And 12, 13 ports are there here. 12 and 13. 12 is connected to the 1 RE, RE1, and 13 is connected to the second RE. Okay, all these line cards are connected to the internal switch port. Okay, that is provided by the switch control board. Okay, it has a planes, that is next level. Okay, we will discuss about more. However, the SCB provides the switch fabric and all the line cards internal connections is handled by the SCB only. Again, this all SCB is connected to the mid plane of the chassis. Okay, this all MPC and DPC line cards are communicating with routing engine each other. Okay, through SCB. Okay, that's why first we have to install SCB first. Okay, after that you have to install routing engine. So SCB houses the routing engine. You can see here. This is the SCB card, switch control board. So this is empty slot. Okay, as of now we haven't installed anything. This is empty plane, empty slot. So in this slot you have to install routing engine. Got it, right?
Yeah, and can you please come back to the diagram once again?
This one.
Yeah. So what is the full form of this MPC and DPC?
Modular port concentrator and dense port concentrator.
Module port?
Modular port concentrator and dense port concentrator. So you can type on Google MPC.
What is the difference, like modular and dense port?
Yeah.
Is something different?
Yes, yes, there is a difference. So in the DPC cards, you know, you will not find any MIC cards. Okay, DPC cards are fixed one. Okay, the architecture of DPC cards is old one. Okay, these DPC cards are old line cards. Okay, you will see the fixed interfaces. However, in MPC cards, according to your requirement, you will install this type of mix. Here you will see, right, Ethernet MIC and SFP MIC and serial console cable MIC. So according to your requirement, suppose your end customer having Ethernet port, you can install this MIC card and you can connect it.
That depends on the handoff, right?
Yes, yes, yes. That depends
Okay.
on your customer requirement. So you have flexibility to install whatever the MIC card you have to install here. In the DPC, you don't have that flexibility. Okay.
Actually, it is like a
Fixed one.
fi-
You can.
like a card where we have the IP addresses assigned, right? Interface.
See, these DPC cards also have interfaces. That interfaces are inbuilt one.
Okay.
Okay. Yeah. So you have to buy the line card. Either all will having the Ethernet ports or all will having the SFP ports. Okay. That flexibility is not there in DPC. In MPC, you will have this flexibility. You can install either, Ethernet MIC card or SFP MIC card. Yeah.
So this model is a MX router because it
Yes,
has
yes.
only the routing.
MX960 router. I have just taken this high-end router, but this architecture is
Sir?
same. Yeah.
So this router is used in also ISP level.
Yes. We have to, everyone is using service provider environment or using MX960. That core layer, right? The core ring, you will
Core
see
layers.
core layer, and they will have their own data center, right? The core ring. So the core layer, they will use this MX960 routers, MX series routers.
Okay, sir.
Yeah.
So this is just because MX is only when route it is only has a routing engine, right?
Yeah, it has a routing engine. Even QFX switches also have routing engine. And
I was asking like in what terms we differentiate, because earlier you said MX, then another series of routers was there, right? Like
yes,
Firewall, QoS.
I will show you here. If you see here, right, this is, I have taken example of this router. Okay, you will see MX 2010 model, MX 2020 model. Okay, MX 240, MX 480. Okay, so you will see from here, right, from here to here, you will see the routing engines and SCBs and PFEs. But one moment. Yeah, these are the routers. Okay, these two are the routers where the routing engine is inbuilt. Okay, you will not the routing engines are not replaceable here. In this chassis, the routing engines are inbuilt. So similarly, here also, these are the switches. QFX switches, you will see, we will work as a layer 3 switches also. There you will see the routing engines also. So this is the enterprise switches I have provided here. Okay. In especially, you will have types of platforms, MX and M and T series and ACX. Okay, ACX series. This is high-end level. This M and T routers are legacy routers. In the year of 2000 and 2010 between, right, they use this M and T series. Okay, these are legacy routers which we are not using. So currently the trending one is MX and ACX. Okay.
So my question was, when it has a routing functionality, then it is MX series routers.
As well as ACX series routers.
A6 series routers. If
Yes.
it is a switching switch, actually, then it is a you said some what was it, ACE?
In switch also, that routing in switch also you have to install Junos, right? So it is also an inbuilt routing engine.
Okay, but it has a switching functionality as well.
Yes. It has a, each and every model have separate
So
Junos.
then the term changes from MX to EX, right?
Yes.
Series. Okay.
Yeah, series is the change. Series will
What
change.
was that you said? Some lookup table that is part of this routing function, or
No, lookup will perform both on routing engine as well as PFE.
can you come to that slide where we had that LT lookup table?
Here, right?
Right. Yeah.
So these are the ASICs, application specific integrated circuits. These are the chips, okay,
Uh-huh.
which will be designed and which will be located on this line card.
Uh-huh.
This is the MPC line card, okay.
Uh-huh.
This is the MPC line card. You will find this lookup chipset on this line card. So whatever the packet will be arrive on this interface, right? Okay, this is IX. So initially at the SFP background, you will say IX chipset. After that, it will do the lookup. So what routing basic routing function, what it is do, what it will do, it will send and receive the traffic based on the IP addresses, right? So what it will do, it will check the destination IP address. If any packet is arrive at me, I will check the destination IP address where I have to send this packet. So based on the IP address, you will come to know whether this IP address is pointing to me or it is pointing to the another router. Okay. So that process is handled by this lookup chipset. So each and every functionalities, right? You will have different chipsets which is located in MPC line card. And someone is asking another query. 1 minute. Okay. Yeah, fabric, right? Fabric in the sense the throughput. Suppose 100G speed. So this is a throughput, right? Suppose each and every generation line card you have throughput 80 Gbps per second. So this throughput should handle, right? The chassis should handle this throughput. How it will handle? You need SCB cards. You need switch control boards. Okay. This switch control boards will handle the throughput. Okay. That is called fabric. Okay. It's a keyword which we use in Juniper terms. Okay. And yes, it will support the satellite. These are the satellite ports which will support. Yeah. Anyone having any query?
And for QoS specific, there are separate routers, separate series of routers.
No. For QoS also, QoS, right? Quality of service, you're saying.
Yeah.
No, this line card will support QoS functionalities.
Because we saw another series, right? MX,
yes,
EX, then there's one more, right? What was that?
ACX and SRX series.
Yeah, so they are for firewalls or what?
SRX are firewalls.
ACX is for routing.
Routing only.
Okay.
High-end level routing.
So inbuilt, they support QoS as well.
Yes. Inbuilt, they will support QoS as well. For QoS functionalities, you have separate chipset. This is QX.
Okay. And
you have separate ASICs. Yeah.
MQ for?
Sorry?
MQ chipset for?
Memory chipset.
Okay.
So to handle these packets, you need memory, right? You have to store some memory, right?
Okay.
So this is a memory chipset.
And why we have XM in that generation 1.52?
The terminology is changed. Just like we have a Snapdragon processor, right? 8 Gen 1 something. The generation to generation, the keywords are changed. However, the functionalities are same. Here you can see the IX and MQ combined together, and they used to call XM. Okay. Here XL, XQ, XM. This all combined, and they will build one chipset only from MPC 7 line cards. Eagle
right
chipset.
Now we use generation 3 routers.
It depends.
Okay, it depends on the speed that we have.
Yeah, line cards. Yes. So you will have Agent Smith line card. You will have MPC type 1, type 2. Different types of line cards you will have. MPC types. So if you want me to dig more, so this is the blog, right? In this blog, you will see a lot of information regarding MS architecture. So types of line cards I will show you here with. So here it is. This is the one, and types of line cards: type 1, type 2, type 3, up to type 10E. So you will see types of line cards here. 1 second. Yeah, here next generation line cards. In routing engine also you will have different generations, type 1 and type 2. Yeah, here you will see, right, MPC1 model, MPC2. This is agent Smith card. So you will see 16 10G ports. Okay, so MPC3A, MPC4A, and MPC5E, 6E, next generation MPC2E cards. Okay, you will have from MPC7E onwards, you will see Eagle chipset. Okay, so MPC10E also came in 2020. Okay, these are the types of MPC line cards you will see. Yeah, we'll provide. Okay, so the management team will provide this information, slide as well as link. Okay, everything, everything I will provide to you guys. Okay,
So in this course, are we going in detail about SRX routers or
no,
just
MX routers,
only MX?
not MX routers and all. The
Uh-huh.
basic function of Junos fundamental, Junos OS,
Okay.
and how you have to configure the protocols in Junos. So you will be familiar with the Junos CLI, Juniper CLI,
Okay.
and all the protocols will cover here. Okay, so we will concentrate on more routing and little bit switching as well. Okay. Okay, so SRX is if you know how to configure, right, the basic things, you will configure other protocols also in SRX. In SRX it will have more functionality to provide security features. It provides more security features. In terms of MX series, if you need to provide some NAT services or security services, you need to install separate line card, but in SRX it is not like that. Okay, any other queries, so that we can start we'll start lab.
Just for as a topic of query, this to know more about SRX, under which course that comes for SRX?
That is next level. The basic level is JNCIA, Junos. This is so this is common for each and every domain.
Okay.
And security, if you want to learn security, you can go through the security videos. That SRX comes under security. So we will have separate course for that.
Okay.
For security, like CCNA routing and switching earlier, security, data center, like that. Yeah. So earlier what they did, they covered all the topics in one certification only. Now they split it recently. Yeah.
And if in the same MX series routers, we can have this security line cards installed as SRX or different series routers it is?
SRX series. These firewalls are SRX series. I will show you here. I have already. So these are the SRX.
Yeah, showed it. Yeah.
SRX 220, SRX 110.
Okay.
Yeah.
Thank you.
Yeah. So this is the basic hardware. Okay. So Juniper is based on hardware only, right? So that's why I'm explaining some of the few hardware models, and I have taken one example of MX960 and explain each and every component, okay, of this MX960. And so these are the PFE components. So PFE components are SCB, this MPC line cards and MIC cards. These are the PFE components. Okay, routing engine components are this routing engine. Okay, routing engine and the daemons. Okay, so in at the rear end you will see the fan tray and power supply modules. Okay, so here you will see the craft interface panel. Okay, this is craft interface panel. So you will see the LED status of each and every line card on craft interface panel. If anything goes wrong with line card 0, this is 0, line card 0, right? You will see the red LED on here, craft interface panel. That's how you can identify physically. If you have access, right, you can check some commands, show chassis hardware detail or show chassis FPC detail. You will see whether this FPC slot 0 is offline or online. I will show you in the next next session. So if you have any queries regarding software architecture and any regarding any hardware related, you can ask me. If you okay to good to go next session, we'll go it. Any other questions? You can free to ask. Okay. And yeah, SRX will provide router and firewall both functionalities. However, firewall will have more features than routing devices. For if security device, right, security features, this is a MX960 router. If this device should support any security features, right, NAS services or any IPsec tunnels or any other security features, you have to install separated line card, and also you need license. Okay, you need license. For SRX you should not. Okay. So one more thing I would like to inform you. So these two are license based devices, MX104 and MX80 chassis. Okay. Yeah.
What do you mean by license based? Others don't need license, or?
Yeah, actually, let me. Yeah, here, right, you will see 10G port, 4 10G ports here. Okay. This is entire we call MX80 chassis only. However, if you call MX5, right, in MX5, you will come, you will see this router. Okay, you will have one mic card and you don't have access for this 10G ports. If you want access, right, you need a license for this empty mix slot and this 10G ports. If you add license, right, then it will become MX10. Okay.
You mean those 10 gig ports, if we need access, we need license, huh?
Exactly. So here you will see two mic cards. Okay, mic 0 and mic 1. Okay, mic 0 and mic 1. If you buy MX5 chassis, it will come with only mic 0.
Okay.
It will not come with here. It is empty slot, and you don't have access for this 10G ports.
Okay.
Okay. If it is MX10, right, you will have mic 0 and mic 1. If it is MX10, you will have access to mic 0 and mic 1.
Okay.
However, you need to install license to access this mic 1.
Okay.
Okay. And if it is MX40, you will have mic 0, mic 1 access as well as two 10G ports.
Oh.
That is called MX40.
Okay.
If it is MX80, right, it is fully loaded features, or you will have access for both mic cards as well as 10G ports.
Oh.
Yeah. Similarly, you will find it in MX104 also.
Okay. Okay.
Yeah. These are the license based devices.
Okay.
Yeah. And chassis, this is chassis. This is called chassis. Engine chassis, right? In engine, you will see a lot of ports. Similarly, this entire thing is called chassis. In this chassis, you will install these line cards. Okay. See, this is MX480 chassis. So you will install line cards horizontally. In MX480 and MX240, you will install line cards horizontally. However, from MX960 to 2020, you will install all line cards vertically. Okay. This is chassis. And this chassis, you will have slots. In these slots, you will install routing engines and FPC, MPC line cards. Yeah, chassis is called dabba. This entire chassis. Each and every model have their own, identification. Like MX240 chassis looks like this. It has 4 slots. MX480 it has 8 slots. 960 it has 12 slots, and so on. Okay. Chassis is called this dabba, where we will have all slots. Yeah. Rear end you will install power modules and fan tray. Okay. Yeah. Any other queries regarding hardware? Can we do lab now? Can we start doing lab? How it look likes and everything?
Yeah.
Yeah. Okay. Cool. Fine. No more queries, right? Okay. Yeah. Go to lab. Fine. So we will provide you the access. Okay, to you guys. So VM. So once we will provide you the credentials to you. Once log into the EVM, right? So you will see this setup. So this is Cisco. So if you want to configure any protocol between Cisco and Juniper, you can practice here. Okay. However, I'm concentrating on Juniper only. I want to teach you how is the CLI of Juniper and everything, right? So let me show you. So even if you buy any new product, any new Juniper product, right, you have to turn on the device and you have to connect the console to the routing engine. In the routing engine, on the routing engine, you will see management port and console port. Okay. So once we start the device, so this is a CLI. Oh, it is expired. Why it is asking credentials? One moment. Okay, if you want to take any break, right, 5 minutes of break, you can take it, and meanwhile I'll come back with the lab. Okay. Hello.
Yeah, sure.
Okay. Yeah.
Yeah, sure, sir, sure.
Take 5 minutes of break. Okay, and we'll come back. Yeah. Okay, guys. Hello. Okay. So when you initially buy any product, right, you have to turn on the device. Once you turn on, right, you have to connect the console cable to the routing engine. So you will see console port on routing engine. I will show you here. I think someone you already might know. Okay, if you see here, right, this is the routing engine. Here you will see the console. So this is the console port. Okay, so this is a console CLI where you will see. So initially, so when you buy a new product, right, it will show, it will ask your login credentials. So the login is root. Okay, we will see root. One moment, guys. Okay, so see here. So once you enter the username is root, right, you will see the shell mode. So at the rate percentile, right, so this is called shell mode. Okay, so you need to enter CLI. So this is the operational mode. Yes, console port is a part of routing engine. So this is a console port. Console port you will identify on routing engine. So this is the routing engine. You will see, right. One moment. So you will see this is a routing engine. Okay. In this routing engine, you will find three ports: Ethernet port, console port, auxiliary port, and USB port as well. See if you see here, right. This is a part of routing engine. Okay. Yeah. So once you power on the device, so it will ask you the login credentials. So initially you didn't configure anything, right? So you have to enter root. After entering the root, it will navigate to the shell mode. So at the rate percentile, this is shell mode. Okay. And if you want to go to the operational mode, you need to enter CLI. Okay, this is called operational mode. In this operational mode, you can perform the show commands. If you want to monitor or if you want to perform any troubleshooting tools, right, ping, trace route. Okay, if you want to troubleshooting or if you want to check the device status, okay, you can perform the commands. You can see everything on operational mode. Suppose show chassis detail, show chassis hardware. So you will see the hardware information. Okay, what are the hardware? So this is a virtual, right? So since it is a virtual, you will see all VMX and virtual FPC. So you will see mid plane, and this is chassis and routing engine. Okay, all the hardware components. If you execute show chassis hardware, it will show you the all hardware components. What are the hardware components which are installed on the chassis? Okay, it is CB. Okay, it's CB in the sense control board, switch control board. Okay, and these are the FPC. Okay, FPC slot 0. So in the real time, this is virtual, that's why it is showing like that. So this is a real time device. Okay, So this is a real-time device. When I worked, right, I have taken the output like that. So this is a real-time device. This is MX480 device. If you execute show chassis hardware detail command, right, you will see all this hardware inventory. Okay, this is a chassis platform is MX480, and the mid plane. This is the mid plane port number, and this is FPM board, and these are power supply module, power entry modules. Okay, 2+2, and this is routing engine. Okay, routing engine 0 and routing engine 1. Okay, each and every hardware component have their own serial number. Okay, if anything wrong with this hardware, right, we can replace it. If you have contract, proper contract, they will process RMA and you will get a new product. Okay, so here you will see PEM modules and routing engine 1 and 0, and this is control board 0 and control board 1. Okay, so this is control board 0 and control board 1, and this is type of control board, enhanced MXSCB. So routing engines, all I said, right, as I said earlier, FPCs have types: FPC type 1, type 2, type 3. Similarly, routing engines also will have types: general routing engine and next generation routing engine. Okay, routing engine and next generation routing engine. Similarly, control board also we have types. Okay, SCBs and enhanced SCBs and enhanced SCB 2Es. Okay, here you will see FPC 0. This is MS DPC. MS DPC in the sense multi-service DPC. Okay, it can support services functions like NAT services, IPsec services, like that. And this is MPC 3D. On slot 1, we have installed MPC 3D line card. This is Agent Smith line card we used to call. Yeah, this is MPC 2. Okay, on FPC slot 2, we have installed MPC type 2. So these are the hardware information. So we can execute this command on operational mode. Okay, show chassis hardware detail, no forwarding. Okay, show chassis hardware detail, no forwarding. If you actually, this is VMX, right? Cannot support. You can execute this command, show chassis hardware detail. Since it is a virtual, it will show you only limited information. In real time, you will find the information like this. Okay, this is the one. And another show commands I will show you. You can execute it on operational mode. So if you want to see the version, okay, what is our version currently running this device? Junos version, you have to execute this command, show version. Okay, show version, you will see the type of chassis model and you will identify the version, Junos version. And show chassis alarms, you know, this alarms, right? I have already told you there is a one daemon is there, chassis ED daemon. Okay, it will monitor each and every hardware component, and it will, in case anything wrong with the hardware component, it will trigger a alarm. Okay, so if you want to control any Juniper devices, right, you need to execute, these are the basic commands to check the device health status. You have to check show chassis alarm, and you will identify this information. In case any hardware issues are there, right, any hardware alarms, it will show you. It will show you the timestamp as well as the description. Here it is backup RE activate. So what is mean by backup RE activate? I will tell you later. Okay. And these are the hardware details. And this is the show system process. Okay. I told you, right? RPD, MGD. So you will see RPD. What is the process? CPU process for RPD. So if it is more than 20%, 30%, up to 25 to 30%, it is okay. If it is going beyond that, right, there is a more pressure on RPD. So you have to troubleshoot according to that. Okay, this is a command. You can check the process. What is a system? High CPU utilization. Okay, high CPU utilization in the sense you have several daemons, right? Each daemon have their own responsibilities. So if you want to check what is the CPU utilization for each daemon, you can execute show system process extensive and identify the CPU utilization. RPD, it is utilization is 0.68% only. This is a CLI, DCD. Okay, and this is a chassis D. Okay, these are the different daemons. You will see in see, this is PFED. Okay, this is MGD 0.00% only. For class of service, you have separate daemon DCD. So you will see different daemons for each and every process. If you want to identify what is the CPU load for each process, you can execute this command, show system process extensive. Okay, if you want to see each and FPC detail, right? Simple command, show chassis FPC detail. On slot 0, the FPC is online or not. If it is anything wrong with the FPC coordinate, it will show you offline here. Okay, so here slot 0, slot 1, slot 2, every line card is online. Okay, these are the boot log messages. Okay, when you reboot the device, it will capture the log messages and it will show you here. So you can see environment, show chassis environment. So all all line cards, you will see here, and each and every line card temperature and their status you will see here, show chassis environment. So these are the power entry modules, these are the routing engine, the status is okay. So this is the temperature. If the status is not okay, and you need to troubleshoot it accordingly. So these are the basic commands, show commands, you can execute it on CLI mode. Okay, this is the CLI mode, operational mode. Okay, show chassis FPC, sorry, you will see here FPC detail. Okay, see here it is showing state is online, temperature is absent. Okay, this is virtual now, you will not see much information here. Sure, you can practice. Okay, this you will have the lab access, you can execute these commands and you will see the information. Okay,
Which would be a debug command in Juniper?
there is no debug commands here. So here you will configure the trace options instead of debug. Okay, configure trace options, and you need to call, in Cisco for BGP you need debug IP BGP something, right? So if you want to troubleshoot for BGP any protocol OSPF or something, here you can take the TCP dump, or else you can collect the trace options. Okay, so trace options is the feature in Juniper where you can capture entire packets regarding protocols.
That you'll cover later, right?
Yeah, that I will cover later. This is the initial session, right?
Okay,
So
okay.
the basic CLI I'm saying. So initially you will see the it will ask you the login credentials. Once you enter the root, it will ask you the shell. It will show you the shell mode. Okay, routing engine shell mode. If you want to enter into the CLI, you need to execute CLI command, and you will enter into the operational mode. So in the operational mode, you will execute some show commands, and if you want to check the device health status, or if you want to run some any troubleshooting tools like ping, traceroute, like that, right? You can execute it on operational mode. If
Suppose
you want,
if we need some help for the show command, if you put show at question mark, will it show those commands?
yes, it will show you. That is what next, next thing. So if you want to execute any command, show something chassis. Suppose show chassis, after that, what are the possible options you want to see, right? Just put question mark. It will show you everything. Okay. Not only for chassis hierarchy, you can see show system process, give question mark. It will give you extensive output. If you want to check, you can see. Yeah. If you give question mark, it will show you the what are the possible options we will have after this command. Yeah, it will help you. So I will show you now. I will show each and everything. So if you want to configure, right, anything, if you want to configure device IP addresses, any protocols, anything, you need to enter into the configuration mode. How to enter into the configuration mode? Just configure, enter. So you will see ash. Okay, here. This indication, it represents the operational mode, and this indication, it represents the configuration mode. Now here you can configure. Okay. Please remember now in Juniper device, initially you don't have any user credentials. Okay, the default one is root. Okay, once you turn on the device, The default one is root. Okay, it will not ask you any username and password because you didn't assign. So initially you have to give root and enter into the configuration mode. After that, if you want to execute any command, any configuration, you can execute. Okay, what are the mandatory configuration you have to do? I will explain you now. Okay, I have this document for you guys. Okay, so as I said, there are two CLI modes. One is operational mode, one is configuration mode. So in the operational mode, you can execute all show commands and you can monitor and troubleshoot the networking operating system. Okay, that is operational mode. And the configuration mode, you can configure whatever the configuration you want to configure, assign the addresses on interfaces, general routing information, protocols. If you want to create users, everything, all configuration things you have to do in configuration mode. So after executing a configure command, it will move to the configuration mode. So this is a hierarchy. So if you want to configure any protocols, right? So protocol hierarchy, you will see protocols. After you will see BGP like this. Let me show you here real time. So some set here you used to call set. Okay, if you want to configure anything, the keyword is set. Okay, set simple protocols. What protocol you want to configure? Suppose OSPF. Okay, OSPF and give question mark. What are the possible options after that? So it will show you. Set protocols OSPF area 0. If you want to configure any area, right? Here you will see area. If it is 0, you can configure area ID 0 and call the interface. Okay, simple. Here in Juniper, the configuration is very easy. Within one command, you can configure the protocol within one command. Other vendors, you need to call the networks. You know, there are 3-4 commands you need to complete the protocol configuration. In Juniper, you can configure the protocol within one single command. Okay, so in the area you have to call the interface. I will show you the, I will explain you later. So I'm just explaining you how to do the protocol configuration or other configuration. See, this is protocol hierarchy. Okay, suppose if you give set and give question mark, it will show you the hierarchy, what level you are, which one you want to configure. Chassis things you want to configure, or any fabric level, hardware level you can choose, or protocol level you can choose. Okay, here protocol routing instances like that. Okay, so this is a hierarchy under protocol level. Okay, here I already showed you right here. Set protocols, give question mark. This is the hierarchy. These are possible completions. Okay, okay, okay. And in Juniper, there is a hierarchy level. If you want to configure anything, the configuration is like hierarchy level. Okay, it will be in hierarchy level. After configuring all the configurations, right? If you want to show the configuration, it will show you a programming, programming syntax level. Okay, it will show you the configuration. It will show you like, programming, like closed brackets and open brackets like that. I will show you later. Okay, so in edit hierarchy level, suppose edit, right? Here you can see edit. So why we are using edit here? Okay, what is edit hierarchy level? Okay, suppose if you want to configure any protocol, suppose set protocols OSPF area 0 interface, something I'm configuring OSPF, some some interface I'm calling. So if I'm executing the same command multiple times, set protocols OSPF area 0 multiple times, so it will be burden on us, right? If you are repeating the same command multiple times, it will be, the time will be time it will take a lot of time. Okay, so to avoid that, you can go to the hierarchy level. So here set protocols OSPF area 0 is common for all the configuration. So if you want to enter into that hierarchy, simple edit protocols OSPF area 0 and enter. So you are under this hierarchy now. Now you no need to repeat this command again and again. You no need to repeat this command set protocols OSPF area 0 again and again. You can just enter into this hierarchy and execute. Just call the interfaces. Okay. Area 0. Just give set area 0. Area 0 already given. Just give set interface. That's it. So edit hierarchy is like if you are repeating the same command multiple times, you can enter into that edit hierarchy and you can configure it. Okay. I hope you understand, right? If you have any queries, you can ask me. So this can save some time for us. Okay, you cannot repeat the same command again and again. You can just enter into the edit hierarchy and run the commands, execute the commands, whatever the configuration you want to do it. Okay.
So do we need to, after running the command, will it ask us to, like will it prompt to save the config or something like that, or by default it will save?
No. In Juniper, by default, it will not save. So I think Juniper started, the company was started in 1990s. From the first device to now, whatever the configuration you execute, right, it will not save automatically. You have to execute the command. You have to save the command, to save the configuration, you need to execute commit. Okay, I will tell you later. Okay, in other vendors, whatever the commands you're executed, right, automatically it will run. Okay, it will run automatically. However, it is not saved, it will execute. Okay,
Okay.
but in Juniper it will not execute. Okay.
Okay.
I will tell you what it is exactly.
Okay.
So I'm just going step by step. Okay. Yeah. So this is hierarchy level. Okay. Please remember this edit hierarchy. Why I'm saying this, if you want to refer any tech library documents, any in Google, if you want to configure any protocol in Juniper, right, they will provide you hierarchy level, edit hierarchy level. So if you see that, you will confuse. So just understand what is edit hierarchy. Okay, edit is like if you are repeating the same command again and again, you can enter the level, hierarchy level, and execute the remaining commands. So it can save some time, it can save lot of time. Okay.
So let's say if we are editing something under BGP config,
Yes.
we just say edit set protocol BGP, and
No,
whatever
not set. Set will not come here. Okay.
Oh, okay.
Suppose edit protocols. Now I'm in under this hierarchy. So if you want to go right, so right now I am this hierarchy. Okay, I am this hierarchy, right? So I want to come back. The shortcut key is top. Okay, the shortcut is top. Now I'm not in under this hierarchy. There is no closed brackets. Okay, here. So now I can configure edit protocols BGP. Okay, this shortcut keys, right, I will explain you in the next slide. Okay, just as your 𝐍𝐤𝐳, right, if you want to configure any BGP protocol, so this is common. Every time you need to enter set protocols BGP, set protocols BGP, like that. So set protocols BGP, every time you have to execute this command. So if it is repeating continuously, right, you can enter into that hierarchy level, enter into that statement completely, set protocols BGP. Okay, then it from here you can start set group and group name and give neighbor address and configure it accordingly. So now you are in under this hierarchy. Okay, from here you can continue the configuration. Okay, continue the execute the configuration.
So finally, when we apply, we'll say set protocol BGP or what?
Yes, you have to enter into that hierarchy and configure the commands, whatever the commands you want to do it by using set.
Oh, okay.
Otherwise, if you don't want to go any hierarchy, come back and configure the protocol in a traditional way. So you can use smart way. Okay, you can just go to the hierarchy level and you can execute it. But the thing is, why I'm saying hierarchy level here is, if you refer any document in portal, right, they will provide you the hierarchy level. Suppose right away, BGP configuration something. If you refer any tech library, right, so they will provide you all the configuration at hierarchy level. configuration. See, you will see right here, edit. So if you refer this configuration, you will not understand. So that's why I explained this edit hierarchy. Okay. So right now it is plain edit only. They haven't entered any hierarchy. So if you refer any document, right, they will show you, they will provide you the information with edit hierarchy. Okay. You got it, right? Any questions? You are able to see my screen?
Yeah.
See here. Okay. So edit routing options. If you want to configure any routing options, right? Under the routing options, if you want to configure anything, you can go to the routing options hierarchy and just give this command this way. So they will provide you the information with edit hierarchy. So you don't, I'm why I'm saying is you don't want to confuse. Okay. Okay, fine. We can. Hello.
Yeah.
Yeah, fine. Okay. So if you want to come back from configuration mode, right? From configuration mode to CLI mode, if you want to come back, one moment, let me share the CLI. Okay. So you can give exit. Are you able to see my screen?
We are not seeing anything now.
One moment.
Yeah, now we can.
Yeah. So you can give exit to come back. Okay. To come back the normal mode. So you haven't done any changes, right? You just give no, because it will trigger an error, any error, because I have done some configuration, some commands I have executed. It is, if you want to exit, right, without committing, it will throw you in one pop-up. Whatever the configuration you have done, it is not committed. Okay. Suppose I'm giving no. Okay, exit aborted. Now I want to do commit. I want to save the configuration. It will validate the syntax. Okay. First, it is throwing any error. Okay, it will check, it will throw one error. Okay, root authentication is missed. Please remember, this is very, very, very important. When you buy a new product, whatever the configuration you have done, right, if you want to execute that configuration, first you have to configure root authentication for your device. Okay, root authentication is mandatory for each and every Juniper device. Before executing any configuration, you have to configure root authentication. How to do that? Set system root authentication plain text part plus password. After that, give password some lab123 lab123. Okay, I have assigned one password to this device. Next, if you reboot this device, it will ask you the credentials. Okay, username is root and password is lab123. Root level, this is root level authentication. Okay, root authentication password I have configured. Now I can execute the commit. I want to save this
Any
configuration.
Juniper router, this is going to be the default behavior.
Sorry.
For any Juniper routers, this is
Yes.
going to be the
Yes.
default behavior.
Yes. You're right. So if you see show configuration, right, it will show you in the programming, programming level. So closed brackets and open brackets. Okay. If you want to see display set format, this is the command, show display set. So you will see, this way you can confuse it. So go to the configuration mode and execute this command, and you will see whatever the configuration you have done, right, you will see here. Later you will come to know all these things. Okay, the mandatory thing is you have to assign root authentication password. So we have assigned it, and we did some commit. Okay, now you are able to come back in operational mode.
So that command again, set authentication, what was it?
One moment, I will show you. Here you will see set system root authentication. So this is the command you will we have done here. Set system root authentication plain text password. If you want to note it, and you can note it, please.
So
this is a mandatory command. Okay,
this plain text password cannot be MD5. It should be plain text. Is it like
yeah,
that?
So there is a different levels you can see. I will show you here. Set system or root authentication could be anything. RSA and DSA. You can give any any type of authentication.
Okay.
Okay. Here I have selected plain text password.
Okay.
Okay. Yeah. Oh. Okay. Okay. Fine. So there is a shortcut key. Okay. These are the keys commands. Okay. Edit hierarchy level we have already come to know, right? And exit. If you want to come back, you can give the command exit. Okay. And up and top. Okay. Up is like I will show you here. Set system root authentication, right? Something protocol I will configure. 0/0/1. So if you give up, right? Okay, we are on top level. Okay. So it will go back one step. It will go to the one step back. Okay. So you can use this up keyboard or top keyboard. Top is it will move directly to the starting point. So this is a hierarchy level, right? So I need to go to the edit hierarchy to show you that. Edit protocols OSPF area 0. Okay, now we are under this hierarchy. Protocols OSPF area 0. So if you want to go one step back, right? Just give up command. It will go to the OSPF level. Again, if you want to give up command, it will go to the protocols level hierarchy. And give up, it will just go to the top level. Okay. You can simply, if you're using hierarchy mode, right? You can use these shortcut keys. Okay. We are already in top level. You can just execute top, already in top level. Similarly, set protocols OSPF area 0. Some interface. Edit hierarchy. So now I'm under OSPF area 0 hierarchy. So you can use top command. You can come back directly on top level. Okay.
We are now in the configuration mode, which is out
Correct.
of the OSPF protocol.
Correct. If you want to by step, right, come back, right, you can use up keyword, up. If you want to come directly, you can use top.
And
Okay.
does it support this history command? Like what all commands that we made in this session?
Yes. Run show history. It will show you. I think here it will not. There is a show system. One second. You can see the history. There is a separate template is there in the logs. Interactive commands. Show interactive commands. Yeah. I think here it will not showing this command in this VM. Actually, there is a command. If you see show interactive commands, right, you will see what are the commands you have executed. Yeah, here it is there. Okay, which user executed which
Okay.
command, and at what timestamp it will show you, and the process MGD, right? So it will show you, and user it will show you, and what are the command you have executed, it will show you everything. Okay, the show commands which I have executed earlier. Okay, yeah. Okay, so show log interactive commands is the command where you can see the history. Okay, so we have already completed, you know, this process. Once you log on the device, turn on the device, right? So it will ask you, it will ask you the user ID root. After giving the root, okay, login as a root and give CLI, and you will enter into the operational mode. And CLI to, if you want to enter into the configuration mode, you can go to the configuration mode. Okay, yeah, these are the commands where you will see all in operational mode. Okay, I want to come back, exit. Yeah, I will give yes. Okay, see here, these are the commands you can perform under operational mode. If you want to configure, you can go to you can configure it by using configure. If you want to clear any statistics, system statistics, you can use clear. Okay, if you want to reboot or restart any line card, right, you can start using this request system, sorry, request chassis. Okay, chassis level, request chassis. So if you want to turn off the FPC 0, you can use this command, request chassis FPC slot. Okay, so you can use that command. And restart, you can restart the, you know, routing engine. Okay, if you want to configure, if you want to save any file, you can use save. So all these commands you can execute it on operational mode. Okay, and okay, so if you see, right, actually you have to analyze that issue offline. So in every router, in every device, networking device, you will see the messages, log messages. Okay, you will see the log messages. If anything happened with the devices, right, any protocol or any hardware component, the all the errors will be triggered in the log messages. Okay, I told you there is a chassis daemon which is handle all hardware components in the on the chassis. So to check that, show log messages. Okay, these are the log messages. Okay, similarly, show log chassis d. So these are the chassis d messages. Okay, so you want to capture these logs and you have to analyze the issue offline, not on the CLI. Okay, these are the files. Okay, oh, here it is not showing any directory because this is a VM na. Okay, so if you want to, you know, collect all this file, right, all these files are located in /var/tmp. Okay, /var is a folder. You know, in routing engine you will have a disk. Okay, memory disk. Okay, in that memory disk you have a folders, var folder. Okay, /var/tmp. Okay, this is a path where these log messages are stored. Okay, in /var/tmp, this log messages will be stored. Okay, all show log interactive commands. Okay, show log interactive commands and show log mastership logs. Okay, all these logs, right, all these log files will be stored in /var/tmp, and this path is you know, this directory will be located in routing engine. Okay, so if you want to collect these files, right, so there is a command, you have to execute this command. Okay, in case in your in your organization you are using Juniper devices and something wrong with any hardware, and you have raised a Juniper ticket. Okay, so they will ask you the logs, how you will collect the logs. Okay, also if you want to analyze the issue yourself, right, you need to analyze the logs, what exactly is the issue, at what time it is triggered. So if you want to analyze these logs, you need to collect the logs and you know, analyze offline. So how to collect the logs? This is the command: file archive, give compress, and give the zip format. Otherwise, if you are using any FTP server, right, you can give the FTP server path here. Okay, basically we will give the command.
But here, actually, we have to come to /var/tmp and run that command.
Yes, this is a command. File
We are right
archive.
now in tmp directory then.
Yeah, here there is no directory actually. This is a VM now. So in the real time, you will see the directory. Okay.
So, but in a real time, we have to do /var/tmp and then do this file archive command.
You
Is it
can
like
give
that?
path. You can give the path directly here.
Okay.
File archive, and what is a file? It is so /var, right, where the file is navigated. So navigate the path tmp/messages. Some
Okay.
path give, and you know, you can give TCG format here. One moment. File archive compress. Yes, this is a command. You need to compress, right? File archive compress, and the file name you have to give. So the destination path is where /var/tmp, the original one. Here there is no directory. I'm just executing, it will throw you error because there is no directory. In the real time, you will, wherever the file is located, right, you're going to compress that file. Just give that path /var/tmp slash the uh, something like, give any file name, something today file.tcg, and execute it. Okay, all the files will be compressed and will be in tcg format. That will be whatever the files are under this tmp folder, right, all files will be in tcg format. You know, they will compress it. It will compress all the files, and it will create a one zip format, and you can collect that files through FileZilla or VNC viewer, right, VNC, and you can drag and drop the file, and you can provide to the Juniper, as well as you can analyze it. You can extract it and you can analyze it.
Can you repeat that last step? So after we compress.
Yeah, after you compress, right? If you have the reachability to the device, you can log in through VNC or FileZilla. It will show you the GUI mode. Okay, one left side it will show you the desktop, right side it will show you the router directory. You just can drag and drop. That's how you have to collect the files from the router.
So we are actually copying this file to that software, right?
We
Is
are
it like that?
copying the files from router to our computer.
Computer. Okay.
Yeah, by using software, FileZilla or VNC software.
Okay.
So you have compressed the logs, and you need these logs, right? How you will collect, how you will analyze on your computer.
Right.
You need to copy, right? So there is a software where you can log in through the software. You can log into the server directly through the software. It will show you the GUI mode, all the files in the folder, right? It will show you. You can just drag and drop it. It will copy it. Yeah, in the real time, that's how it works. Okay, these are the some keys. Okay, I will share this document to you. Okay, you can practice it on the lab. Okay, these things I have already explained to you, and I will tell you the commit. Okay, the commit is a command where you have to save the configuration. So what type of commits we have in Juniper, I'll tell you now. Okay, suppose, okay, I'm entering to the configuration. I'm going to configure you know, uh, some protocols. Okay, configure set protocols, OSPF area, OSPF suppose. Okay, I have done some configuration. Okay, if you want to see the configuration, what are the configuration which is not committed, you can just execute show display set. This will show you all the configuration, and what is the configuration which you are not executed, right? If you want to see that, show comparison command. So here you will see place a symbol. If you observe, right, if you see the plus symbol here, plus in the sense we added the configuration. This is the command where you can see the latest configuration, which is not committed. Please remember, in Juniper, you will have two things: candidate configuration and active configuration. Active configuration is whatever the configuration we have already committed. We have already committed and it is running. That is called active configuration. Okay. So actually this is all I have already done, right? This root authentication I have already completed and I have already done commit. So this is active configuration. And whatever the configuration which is show you here, right? We have just added. This is called candidate configuration. Okay. So the candidate configurations you will see 0 to 49. Okay. 0 to 49. What is this 0 to 49? So initially this is 0. This is 0 block. Okay. So whatever the configuration which is not committed, this is unsaved configuration. This is unsaved configuration which will be located in 0 block. Okay, which will be there in candidate configuration. Once you execute commit, right, it will become the active configuration from candidate to active. Once again, I'm repeating, whatever the configuration which is not saved, which is not committed, that is called candidate configuration. In JNCA exam, you will get one question regarding this: active configuration and candidate configuration. So candidate configuration is which is not saved, which is not committed. That is called candidate configuration. And active configuration is what after executing the commit and it is saved and it is running on the device. That is called.
That portion understood, but you said 0 to 49. What is that?
Yeah. I will tell you that. I will tell you that 0 to 49. Right now I have done some configuration, right? So I'm going to do commit. In the commit, you will see different options. Okay. If you do question mark, you will see different options here. Okay. If you execute commit and quit, right, what it will do, it will commit and it will go to the operational mode. Okay. After successful commit, it will go to the operational mode, commit and quit. Simply, after committing, you have to again enter quit, right? So if you want to save the some time, right, you can just exit commit and quit. It will immediately go to the operational mode. Suppose you have done some configuration right now, the services are running. The services are running, and if you do commit now, right, there will be a outage. Some outage will be there. So if you observe, right, only midnight they will take a downtime, server downtime. Okay. So in downtime only you have to execute these commands. Okay. So you can prefer commit at, you can mention the time. Okay. At what time you want to configure, what time you want to commit this, what time you want to execute this command, you can mention the timestamp you can give here. Okay. Some time, right, show system uptime. If you see, right, it will show you the current timestamp. According to that, I will show you here. Run show system. So this is the uptime. So current time is, this is the current time. Okay. So you can give the timestamp in this format. Okay. Commit at something. You can give it some 10, like that you can give. Okay. This is one option. And another one is commit and check. Okay. In the real time we used to do commit and check. Before committing, we will do commit check. What it will do, it will check the each and every syntax. So you will configure one protocol, any complex configuration you configured, right? So you want to verify each and everything, so you can execute commit check. So in case if anything wrong with syntax, right, it will throw you an error. Okay. It will throw you an error. According to the error, you have to resolve the issues. Okay. You have to modify the configuration and again. Okay. And another one is commit comment. Okay. So the commit comment is like you know in your organization you have done some changes And if anyone want to know what is the why you have done some changes, okay, you can give commit comment and give some description. You can comment, okay, based on the new customer added, some new customer is added, right? So you have done some changes, so you can just add your comment on this. Okay, just give some new customer added. So you have to give comment, message, type any message. So new, one space only it is taking. I think only one space it is taking. Fine. Here you can give some date also, some date and some VPN, some VPN configuration you have done, right? You can mention VPN. VPN for new customer, like that. You can just, based on your understanding, you can give some message here. That is called commit comment. So one question they will ask you, what are the possible options you will see in commit, right? So out of these questions, you will get one question. Out of these options, you will get one question. Okay. And the final one is commit confirmed. Okay. So this will tell you automatically rollback if not confirmed pipeline through a command. Okay. You have done some configuration, and if you do commit confirmed, right, it will execute the configuration for 10 minutes. After that, it will roll back. Okay, you have done some configuration, you are not sure that configuration is valid or not. Okay, suppose you are at your NOC center and the device is located in some remote area. Okay, device is located in some remote area, so you are controlling the device. So you have done some changes and you execute commit. After executing the commit, you lost the device access. What you will do again, you have to go to you have to visit the site and log in through console, and you have to check it. So if you're not sure about the status of the configuration, right, status of the device after the commit, so in that cases, you just to check the configuration is correct or not, in the new design, new implementation or new design, okay, they use commit confirm. So if you use commit confirm, right, it will take 10 minutes of time. Only 10 minutes, sorry, it will only execute 10 minutes. Okay, after that it will roll back. Roll back in the sense it will come back in the previous configuration. Okay, so you can give 5 minutes also if you want. Commit confirmed 5, you can give 5. So if you don't represent, if you don't give any number, right, by default it will take 10 minutes. Or else if you want to give any specific time, right, some 2 minutes, if you want to run this configuration, 2 minutes you can give, or 3 minutes, up to 10 minutes you can assign. 10 minutes you don't need to assign, because if you execute commit confirm, right, it by default it will take 10 minutes. Okay, these are the possible options, for commit. Okay, and here you can see, right, last one we discussed, automatically rollback. Okay, so there are 0 to 49 configuration, previous configurations. That is called that's why I used candidate configuration blocks. So you asked, right, someone is asked 0 to 49, what is that? 0 to 49 is the 0 is the present candidate configuration which is not saved, and 1 to 49 is the already saved configuration, already executed configuration, the previous executed configuration. Okay, I will tell you now. Exit all. Okay, exit. Yes. So hello.
Yes, yes.
Yeah. So if you have any queries, you can ask me. So right now I'm going to explain about 0 to 49 blocks. Okay.
Yeah.
0 is the candidate configuration. Candidate in the sense which is not saved. Okay. And 1 to 49 is the already executed configuration. That is the previous configuration. So far what we have configured root authentication as well as this OSPF protocol. Okay, 2 configurations you have done. Okay, show config. One second. Okay, one moment. Something we have configured. Show compare. We'll check it. There is a new configuration is there which we are not saved so far. So this is a new configuration, right? Right now it is in candidate configuration. Let me execute it. Okay, I have executed. If you after execution, right? This is the candidate configuration. After giving commit, it will move to the active configuration. This is the proof. So initially, whatever the configuration we have done, right, which is not saved, it will show you here. Okay. And after executing, if you execute this command, you will not see any configuration. Similarly, this is plus symbol. We added the configuration. Similarly, if you remove the configuration, let me remove the configuration. How to remove the configuration? Just delete and that's it. Just give delete keyword to delete the configuration. Okay. So the OSPF protocol configuration we have deleted successfully. Now we can see compare. See here minus. So we have removed this configuration. If you remove this configuration, it will represent you in with this symbol. If you added right, it will represent with plus symbol. So this will be also in candidate configuration now. After executing, this will move to the active configuration. Okay. Show compare. Someone asking something. These are not configuration files. These are the rollback. Okay, rollback 0 to 1. Suppose if you right now, we have removed this configuration, right? Just a moment. Just a moment. Okay, sorry guys. Okay, so right now we have removed this OSPF configuration, right? So if you want to add this configuration again, you want to execute this command, set protocols OSPF area 0. So simply you no need to run that command. Simply you can recall it. So rollback 1. So rollback 0 is candidate configuration. Please remember 0 is always candidate configuration which is not saved. Okay, even if you do rollback 0, it will not execute anything. Okay, you have to recall the previous configuration. What is the recent configuration which is saved? This one only, right? We removed this configuration, we have done commit. Okay, let me show you now. Show display set. So right now there is no OSPF configuration. Okay, recently what we have done, we have removed this. Okay, let me recall it. Okay, this will be now this or whatever we have done right recently, this thing will be in rollback 1 block. Okay, there is a 1 to 49 block, right? This entire changes will move into rollback 1 block. So simply what I can do now, rollback 1. If I call rollback 1, right, load is completed. Whatever the configuration changes we have done recently, that will be in block 1. Now we call that rollback 1. We have executed rollback 1. Whatever the changes we have done in previously, right, everything is loaded now. Now I can see now, show compare. Now it is added. Okay, you understood, right? we are recalling the previous changes, whatever the changes we have done recently, right? So 1 to 49, 1 to 49 change, recent changes configurations, it will store 1 to 49. So this is one is the recently one. Now here you have to give commit confirmed, not commit confirmed, you have to give commit. Okay. Yeah. After that, you can see here, show display set. See, this configuration is again. Got it. So this is the simple method. These are the shortcut keys, okay, in Juniper. Okay. If you want to recall the previous configuration, you can simply use rollback operations. Rollback 1, 2, 3.
So just the recent change will be moved into
1.
block 1.
Yes.
Again, we make a change. It will go to block 2, like that. Like
Again,
is it like 49 times
block 1.
make a change?
Okay. Not 49 times. How can I explain? 1 second. Let me take this. Okay. 1 second. Okay. Okay. Now here, if you see, right? Okay. Suppose, okay. Here there are some blocks. Okay. Till 49. Okay. 0 to 49. 0 is the one which we have unsaved configuration. This is the candidate configuration. This is the candidate configuration. Okay. Will be in 0 block. And 1 to 49, right? Whatever the recent changes you have done, right? That will move to 1 block. Okay. Again, if you made any changes, right? And again, if you made any changes and you have done some commit, right? Whatever the upmost recent, right? This will move to block 2, and recent one will be stored in block 1. Understood?
So again, if you make a change, it will go to block 2.
No. Again, if you made a change, it will go to block 1 only. However, the existing block 1 configuration move to the block 2.
Okay. So that means 1 to 49 will be always active.
Not active.
Active
It
not
can,
active,
yeah.
candidate.
It will be in active configuration blocks. Those are active configuration blocks. If you want to recall it, you can recall it.
Okay.
So recent one will be stored in block 1.
Oh,
Okay.
oh.
Okay.
So
Again,
we
if
want
you
to
do
recall any recent change, we'll say rollback 2, rollback 3, like
yes,
that.
yes, like that. Yeah.
Okay.
So that is a simple method in Juniper. There's shortcut keys. So now if I do rollback 2, right? If I do rollback 2, you can see show compare now. There's nothing in rollback 2. In rollback 3, I recalled rollback 3 and show compare. So in the rollback 3, you will see in rollback 3, I removed this. So if you want to remove this configuration, right, you can do it.
So
So what
these
is,
all will be part of active configuration only, right?
yes, active configuration blocks. Active configuration, it is not part of active configuration.
Yeah, active configuration blocks.
Yes, active configuration blocks.
And
0
this
to
comes
49.
after we commit it, right?
Yes, this comes after we committed.
Okay.
Yeah. There is a command at which block the configuration is there. What kind of configuration is there at which block? There is a one command. Okay. Show. Oh, one moment. Show configuration. I will check it. Okay. One moment. Okay. So show system rollback to display set. Okay. Okay. You will see the rollback to configuration. Okay. So 1 to 49 blocks are there, right? So if you want to see what configuration is there in each and every block, if you want to verify, you can give this command: show system rollback 4. If you want to see rollback 4 configuration, you can see it. Okay, this is the configuration. Okay, I think this is the configuration we have done initially. 4 times we have done committed. That's why the configuration is moved to 4 blocks. Okay, this will comes after commit only. So we have done commit for 4 times. So we will see the 4 blocks. Okay, this is the upmost recent, like the 4th block. You will see this configuration.
And where we saw minus, that was the configuration that we made in rollback 2, 3. Rollback.
Yeah, this is the configuration. It will show you here. It is minus and plus. It will show in display set format. That is in, here it will show you whether you added or whether you removed, right? After taking call only, it will show you. After loading, here I load. So this is in config. If you execute this command, right, it will show you what is the configuration in block 0. This is candidate configuration, which is not executed, which is there in block 0. Okay. Now, if I want to remove, right, just give rollback 0 or rollback. If you give rollback, right, directly, it will take rollback 0. Okay. So if you give rollback 0, right, whatever the configuration is there in candidate, right, candidate block, everything will remove. Load completed. So show compare now. So everything is removed. And if you want to if you want to see the configuration, right, show system, not this, run show system. I think this command will execute in only operational mode. Here it is not taking. Now I'm going to commit. Okay, now let me execute it and show system rollback. You can see this is a recent one we have done. And this is a rollback to configuration. I think rollback 3 is not there. Yeah, this is a rollback 3. This is 5. I think 5 times we have done we have executed, right? Commit. Okay, this is the 6th one.
So how many times we commit, that all turns as a rollback, right?
Yes, correct. The recent commit will be stored in block 1.
0.
Yeah, that is the one. Okay, so actually, we have covered two questions here. Okay, in 𝐍𝐞𝐭𝐰 you will see commit, right? After commit, what are the possible options, right? They will ask you one question from here, and the candidate this candidate configuration and active configuration, regarding that they will ask you one question. Okay, and the root authentication also, and the coming to hardware also, they will ask you control plane functions and the forwarding plane functions, where you will see this. Yeah.
So this course will actually help us in clearing JNCA exam, right?
Yeah, 𝐍𝐞𝐭𝐰 as well as some Juniper. You will be familiar with Juniper CLI, as well as you will be good in routing protocols also. How you can configure OSPF of BGP. I'll teach you how to configure BGP. RIP
No,
protocol.
I was asking mainly focusing on the certification part.
Yeah, certification, as well as you'll have a good command on Juniper end of the end of this course.
Yeah.
So yeah, end of the day, certification is value for you, right, for your career. So whatever I came across, so these questions.
Why? Because in CCNA they cover more in depth about other things as well. So in JNCA they just uh, is looking for hands-on on Juniper router just with this basic hardware and show commands?
Yes.
Or?
Yes. Basic this, yeah. Junos OS, how you will familiar with Junos? Okay. Junos syntaxes and CLI syntaxes, and each and every protocol have their own syntax, right? So you will be familiar with these syntaxes.
Okay. And this session is recorded or what?
Yeah, this session is recorded. You will see on YouTube, as well as you will get upcoming sessions.
No, Ramesh. So basically, for today, it's on YouTube. From tomorrow, it's not
Yeah.
on YouTube, and every session is recorded, guys, and it will be updated in your portal after the class within a few hours. Okay.
Okay.
Yeah.
So if you have any queries regarding documents and videos, right, you can contact team
Yeah,
respective.
Ramesh, you have to share whatever the documents you have to upload or you have to provide these guys. You can send me, and I'll update in their portal. Okay.
Yeah, sure.
Yeah.
Yeah, Shahrukh, 3 years. Juniper certificate validity is 3 years. Yeah. Okay, so these are the modes we have discussed so far. So these are the shortcut keys. Okay, in VM, don't use Control W keyword. Okay, if you use this keyword, you will delete the word before the cursor. Actually, in real time, it will delete the word before the cursor. However, if you execute here, right, the session will the session will terminate. The browser, the tab will close. Okay, so out of this, right, these are the shortcut keys. These are the shortcut keys. In real time, you can use these shortcut keys. Suppose if you give Control B, right, move the cursor back one character. So let me execute step by step. Suppose something set protocols OSPF something here as 0. So this is the command which we have executed. So if I use Control B, what will happen? It will move the cursor back one character. So let's see. Control B. See, it moves one character, right? Before left cursor, left one. Control B, Control B. You understand, right? So it will move one character towards left. One option in JNCA, you will get option from this shortcut keys. So you can verify it in lab. You can execute all these keys and verify it in a lab. Okay. Hello.
You mean JNCA? There's a question regarding shortcuts.
Yes. There is a question they will ask you regarding the shortcuts.
Okay.
So they will ask you what Control plus B will do. They will give some options. You have to execute it. Definitely they will ask. 100% they will ask. Okay. Because recently one of my student given the JNCA certification, and you will see all this. They will ask these all questions, basic questions. So,
But when we actually run the config or set, configure the command, just moving the arrow button, it will move, right?
arrow button also it will move.
Okay.
Left arrow, right arrow. See, I'm using left arrow now.
Okay.
Right arrow.
Okay.
And if you want to delete, right, one word, okay, you can use Control U. Here I will show you. One moment. So Control D, delete the character at the cursor. So cursor, wherever the cursor is there, right, it will delete that precise, that character precisely. So if you want to delete entire word, you have to execute Control U. Yeah, Control U, Control X. Delete all characters from the command line. So let me execute this. See, if you want to remove all commands, all whatever the commands are there in one line, right, you can execute Control X or Control U. You can practice. Okay, I will share this this document. You can practice each and everything. Please practice it. Okay, don't forget it. They will ask you one question from this. Okay, after this, so users. Okay, So if you want to, in your organization, level 1, level 2, level 3 engineers are there. So each and every user will have some access. Okay. If you have to give root access, and so there are some classes. Okay. Super user. So you can create a user and you can assign a class to that user. So how to create users is you have to enter into the system hierarchy. Okay. And give login and create users. User 1 is the user, and I will show you now. Okay. Okay. Set system. Set system login. So you will find class, login class. Class is super user or whatever user you can give. Class name also you can give. Set system login, user, and username. Anyone is there? I will take one example. Some Kiran. Sorry. And give class super user. So I'm creating a user is Kiran. Okay. I'm giving class, super user. So if you give super user, right? So he will have all the access. Okay. He can modify, he can edit the configuration, he can do commit, he can do all changes. Okay.
So equivalent to root user, right?
Correct. However, he cannot enter into the shell. Okay. So root user can enter into the shell mode. Okay. So if you want to give any particular, right? If you want to give like read only access, you can give read only. If you give super user, he will have all. Okay. That's it. In real time, they will use read only and super user. Read only will give only for only L1 engineers. They will check the commands. They will only execute show commands. Okay. Like that.
So there is a user who wants to run the TCP dump. What sort of privilege can he? What type of user should we read only?
Read only is fine because it's a command, right? Show command. Monitor monitor interface traffic is a command you can take it. To collect the logs, read only is fine. But if you want to do any changes, right? It's a critical device for us in our environment. Okay, only the authorized engineers, only the good who have the good knowledge, right? Good command on that product, they will only have the super user. After getting some experience, they will give again super user access. Yeah. So I've just created super user. Okay. And you can give authentication. Okay. Under that user, you can give authentication. So here I will show you. I have created a user. Okay. Again, if you give authentication, right, username and password, again I have to enter set system login Kiran, login user, user Kiran, and authentication. Authentication, you can select plain text password. So Kiran 123, I'm giving password. That password I need to give after executing this command. Okay. So I have created a user Kiran and some password to him also. So he can use his credentials and he can log into the device. Okay. So what I haven't done commit now. Here, to configure, right, I have executed 2 commands. Sorry. So I have executed these 2 commands. I have created lot of users. Suppose we have 5 engineers, 4 engineers online. Again, Shahrukh I need to create, Hanifa Khan. So what I can do, I can go to the hierarchy level. Okay. User hierarchy level. So edit, system, login, user. Okay. This hierarchy level I can create. Okay. Edit system login. Now I can give set user like this. Now who is one? Hanifa. Hanifa. Class I can give super user. Okay. Again, set user Hanifa authentication. Plain text password. Hanifa 123 123. That's it. So I've created it 2 users. So you just minimize this to save some time. You can and I want to come back. I use top. Okay, now I can check what is the candidate configuration now. So this is the candidate configuration which is there in block 0. Okay, I have added 2 users. Okay, and now execute commit check whether we have configured correctly or not. So if you want to check it, you can execute commit check. If it is succeed, then do commit. Always do commit check before commit in real time. In future, if you have opportunity to work with Juniper changes, always do commit check. Okay, before executing commit, and do commit. Yeah, commit completed. Now you have to enable services. Okay, uh, actually in real time we will take devices remotely, right, through SSH. So you have to enable services. Say system services. So you will see services SSH and FTP and telnet. Okay, are you able to hear me properly? Any noise is coming because I connected with
Your voice is little less actually, low actually. Can you make it little high?
Can you hear me now? Hello.
Yeah, now it is better. Yeah.
Yeah. Oh, I have changed the internet connection. Just a moment. Okay. Okay, I have configured the services. Okay, system services SSH. Okay, I am going to do commit. Okay, so Hanifa and Kiran I have done. Shahrukh also I will do. So what right now, 1 second. I have done the configuration on this device. Okay, similarly, okay, you will get access, right? You will do configuration on this router. Okay, I will show you how to assign IP addresses interfaces between only these 2 interfaces, and you can take SSH from here to here, and we will end the session. Okay. Okay, I will create a user for 1 moment. Are you able to see my screen now? Okay. Let me create a user for. Hello, can you hear me?
Yes, yes.
Yeah, okay. So set system. So after providing the document and the lab access, you can start practicing, okay? Creating a users and the shortcut keys and assigning IP addresses, okay? Is a user now? Shahrukh Siddiq. Sorry. Okay. So I have created one more user. Okay. After that, okay. So now we learn about how to create users, what are the shortcut keys, what are the modes, CLI modes, and what is the active configuration and candidate configuration, what are the commit operations, and the final one is the basic one is how to assign the IP addresses on the interfaces. Okay. If you, if you want to check what are the interfaces are available on the chassis, you can just execute show interface TUS is a command to check the available interfaces. Okay, these are the interfaces on the device. Show interface TUS. Okay, in the real time, I will show you here. I think it is captured or not. Not sure. Let me try. Show interface. Yeah. In the real time, you will see show interface extensive forward. This is the RSI. It is script actually, where you can run show commands automatically. Okay, it will collect all the show commands automatically. I will tell you this later. Okay, so in the real time, you will see like this. Show interface extensive. This is extensive output. However, if you want to see the available interfaces, what is whether the interface is up or not, in Cisco it is show IP interface brief, I guess. So in Juniper it is just show interface TUS. Okay, you will see all the available interfaces, whether administratively up or not. By default in Juniper administratively up. In Cisco it is you have to give no shutdown command to bring up the interface. Okay, here it is not like that. By default it is up, and the link protocol, what are the protocol you are using here. Okay, and it will show you here. Right now it will show you the link, all links are up. This is virtual, right? Here we have two routers, right? Let me start another router also. On this router it's GE0/0/1. Okay, please remember this interface 0/0/1. Okay, okay, so how to assign the IP address on the interface? Simple. Configure set system interface. What is the interface here? GE0/0/1. Okay, GE0/0/1. Okay, GE0/0/1 dot 0. Okay, unit 0. Why it is asking internet option? Set interfaces. Okay, set interfaces is GE0/0/1 dot 0. Okay, dot 0 is a sub interface, so by default it will take sub interfaces. Okay, by default you have to give dot 0. If you're using different VLANs or different, right, you can give dot 2 dot 3 as well according to your requirement. So initially this is how you have to configure. Set interfaces and the interface name GE0/0/1, right? GE0/0/1 and family. So you will see types of family inet 6.0. Okay, family inet is like it belongs to IPv4. Okay, inet 6 is IPv6. There are different routing tables we have in Juniper. Each different family have different routing table. Okay, I will explain you the families later. Okay, now just concentrate on how we can assign IP addresses on interfaces, how we can build a basic setup lab. Okay, set interfaces, interface name, family inet dot 0, actually the table. Okay, family inet address. So what is the address? 192 dot something. You can take 12.1. You can give /24 directly. You no need to give subnet mask. Okay, this is the command. Okay, just set interfaces, interface name, and the family inet and address and the IP address. You can give /24. No need to give subnet mask. So you will see different families here. If you give question mark, right, you will see inet 6. Inet 6 is for if you're configuring IPv6 address, you can select a family inet 6. Okay, if you're configuring MPLS, so these are the service. So if you configure any MPLS, right, if you build MPLS cloud, you have to configure this family. This is a different one. So basically, if you are configuring IPv4 address, you can select inet. If you are configuring IPv6 address, you can select inet 6. Okay, and address, you have to configure address. Okay, address and you have given this address. So here you can give slash direct, slash notations. No need to give any subnet mask. There is no subnet mask concept here. I mean, subnet keyword here. Just give slash 24. Okay. Show display set. So this is a command which I have configured now. So this is the candidate configuration we have just added and doing commit. So commit is completed. See here, run is the command if you want to forcefully execute the show commands. Actually, this show interface does, you have to execute it on operational mode. However, some of the operational mode commands you can execute it on configuration mode also by using run. In Cisco, you can do it with do command. In Cisco, in Juniper, you have to execute with run show interface does. Okay. So see, this is the this is the interface. This is the IP address I have assigned on this interface. You can see, you can check extensive output also. Sorry. Show interfaces G0/0/1 extensive. So this is extensive output. You will see all the characteristics and all the interface information here. What is the MTU? And you will see IP address at the bottom. See here. This is the broadcast address. This is the assigned IP address. And if you want to check the local table, local routing table, right? Show run route table. Show route. It will show you the route table. This is inet.0. Okay. This is the network, and this is the 12.1 IP address which we have assigned on the interface. Okay. Yeah. So similarly, another router, I will configure the IP address. Once again, this is the other router, right? This is interface is 0/0/0. You have any queries? Is it understandable or what?
That command, the show interface 𝐍𝐞𝐭𝐰𝐴 extensive,
Yeah.
that will also show the packet that is traversing through that interface, right?
Yes. It will show you the all the information on the for the respective interface, right? So how many packets it receives, how many broadcast, or how many unicast, what if any dropped packets, if you have observed on interface, everything it will show you. Interface statistics, everything it will show you. This is extensive output. You can see all the information. If you configure any class of service, you will see queues. Okay. Yeah. Okay. So this is another router. This Juniper 2 is another router. Okay. This is the one. This is the new router. I'm giving root only. So just tell me what are the mandatory things we need to configure now. So how right now it is shell mode, right? How enter into operational mode? What is the command?
Root.
Yeah, I have given root. Login. I logged in as a root, and this is shell mode now. I want to enter into the operational mode. Yeah, CLI. Now this is the operational mode. So what is the command to enter into the configuration mode?
Configure.
Yes, configure. Yeah. Now we are in configuration mode. So once you buy a device, you need to configure mandatory things. First, you need to assign the root user authentication. So how to do that? Anyone remember the command root user? Yeah, root password. What is the command, Shahrukh? So set system hierarchy, you need to go right. Set system, root authentication, and plain text password. Password is lab123, lab123. Please remember the password is lab123. Okay, for these two routers. Now we have assigned the root password. See, we have done that. And what is the configuration we have to do? Authentication, sorry, interface IP address we have to assign.
If you are speaking, we don't hear anything from you. Are you speaking? We don't hear anything.
Can you hear me now? Hello?
Yes, now we can hear.
Sorry, it went on mute. I'm not sure how it. Okay, so I have taken one more router. Here, router name is 3. Suppose you can take the name router 3, Juniper 3. Just you can give. Okay, suppose simple it is 1 and 3, right? You can take 13 series, 13.0, 13.1 and 13.3. Here it is 2, 3, right? If you are configuring IP addresses between 2 and 3 router, it's a 23 network, 192.168, 23.2 you can assign it here, 23.3 you can assign it here. This is simple way, you can easily remember the IP addresses. If you configure the IP addresses between the devices like this, right, you can easily identify. You understood, right? Just take a IP schema in this way. Between 1 and 2 router, you can just take 12.0 network. 2 and 3 devices, between 2 and 3 devices, you can take 23.0 network, like that. Okay, so now I have assigned authentication as well as the IP address, and I need to enable SSH service. Okay, set system services SSH. So these are the mandatory things we have to do. I have done it. Now I need to log in the device from router 2 to router 1. This is router 2, right? So you can assign host name. Okay, simple, you can give set system host name. You can give some router 2. Okay, after doing commit only, it will change the host name. Okay, now it is router 2. Here also I will change set system host name. This is how you have to configure the host name. Okay, set system host name and give router 1. Do commit. Okay, this is router 1 and this is router 2. Okay, now I want to log in from router 2 to router 1. Okay, SSH commit already done, right? SSH I have to do in operational mode. Okay, SSH is the tool, okay, where you can log in through log in the device remotely. So SSH, and what is the device IP? 192.168.1.1. Before doing SSH, you need to check the reachability. Ping is the command where you can check the reachability. 192.168.12.1. Ping, it is pinging, right? Show interface does. So 12.2 is our device IP, router 2 IP. 12.1 is router 1 IP. So after successful ping, you will come to know that okay, the point-to-point connectivity is fine. That's how you have to check. Okay, once you take any devices, right, take 2-3 routers and start practicing and check the connectivity by using ping. If the ping is successful, the connectivity is fine. Okay, now it is pinging successfully. Then do SSH 192.168.1.1. Sorry, it's not 1.1, it's 12.1. Okay, so when you do SSH, right, it will ask you like this: give S, and what is the password? lab123. Okay, I have logged into router 1. See, now I was in router 1. Earlier I was in router 2. Now I logged into router 1. This is shell mode. Okay, CLI. Okay, from router 2 to router 1, I have successfully logged in through root user. If you want to log in through some, I have created users, right? I have created users, like, see here, Kiran and Siddhi and Hanifa. I have created 3 users. I can log in through any one of these user. How we can do this? I'll tell you. Let me come back. Okay, exit. I want to come back router 2 again. Now I came. Okay, I come back. Okay, now I'm in router 2. So what is the command now? SSH. Give the host 182.168.1.12.1. Cannot bypass. User Kiran, right? One moment, let me check the
Should it be SSH, then the user name at, or is it like SSH at username?
Yeah, I'm checking the correct syntax. Actually, when you do login, right, it will definitely ask their username and password. However, here it is directly asking the password. SSH, and what are the possible options showing here? Yeah, it is directly asking the password. Okay, let me find it. One second. I think this is a command only. SSH user @ yeah, this is a command. Okay, SSH username and @ the IP address. So Kiran password is Kiran123. Yeah, we have logged in the router one as a with Kiran user. Earlier it was a root user. Okay, now I logged in on the router one with user Kiran. Let come back again. Let it again. I will try to log in with another user. Who is the Siddhi? Yes, SIDDI. Okay. 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 Fine. Okay. So this is the way you have to log in with user. Okay. So far we have covered how to create users and what are the permissions we can give to the users, and we have configured SSH from router 1 and router 2. I haven't created any users on router 2. However, I have created users on router 1. Okay. We can log in to the router 1 with any one of the user, root or Kiran or another one. Okay. So now you can take two or three routers. Okay, take one new template. Okay. So they will provide you the lab access to you. Once you get the lab access, right, just right click on it and add node. Okay. And how many nodes you want? First, you need to select Juniper. Okay, Juniper VMX, you need to select how many nodes you want. Either 2, if you want to 2, give 2. If you want to 3, you can give 3. Just select 3. Okay. Give 3 and just save it. You will 3 nodes. Okay. If you want to change this name, right, you can just click on it, right click on it and edit it. Just give name. Here you will see name. Just give your name or something, Juniper 1, 2, router 1, router 2. Okay. After that, establish a connections between all routers. So you can select the interfaces. Okay. Choose the interface is ZE. Okay. Not EM0 or FXP. So don't use this EM0 and EM1. Use 0/0/0 or 0 to 3. Okay. Here and here it is 1 or 0 and save it. Okay. Here also establish a connection between 2 and 3 and select 1, and here also on VMX9 1. Okay. EM is the, in virtual environment, if you run this lab in Junos also, JNS3, it will show you is a EM only. EM is a virtual interface that will use for internal purpose. Okay. So naming convention there, the keyword is different, EM2 like that, but in the real time, we used to call these GE interfaces, GE and this gigabit Ethernet interfaces. Okay. This 0/0/0 is representation is like here. I will tell you 0/0/0, right? How we call 0/0/0. So this is FPC 0. Okay. Here the first one is FPC 0. That is called 0/. 1 second. Yeah. Suppose this is the interface. This slot is FPC 0. This is GE interface. So GE hyphen, what is the slot? FPC slot 0, 0/. And here you will see 2 mic cards. This is mic card 1 and this is mic card 2. So this is the interface we are calling, right? 0/, and this interface name is 1, or else it will start with 0, 0 and 1. So we are assigning IP address on this interface, right? So this is 0, GE 0/0/. Sorry, we have to call mic1. This is mic1, right? You need to give mic1. One moment, let me re-explain it. So this is FPC slot 0. Okay. This is GE interface Z0/ and this is the mic0 and this is mic1. Okay, this mic1 name also you have to give here, mic0, and the interface name, whatever the interface name, it is 0. If it is 2, you can give 2. Suppose if you're assigning interface on mic1 card, right, you can give like GE FPC slot 0, 1, and the interface name. If it is 0, 0. This is how you have to represent the interface based on the line card, based on the mic card, based on the interface. Suppose this is FPC 2. Okay, you need to give like GE -2/ like that, 2/, and if it is mic1 or mic0, according to that you can give mic0 and the interface name like that. Okay, that's how you have to represent the interface. Okay, so take 3 devices and practice it. Okay, and shortcut keys I will provide you the link. Okay, I will provide you all this document. You can, according to this document, you can practice it. If you have any queries, you can ask me now. Once you're doing lab, right, you will come lot of you will have a lot of queries. Okay, so
SSH is a daemon. SSH is a daemon, right?
SSH is a not daemon.
It's a service.
It's a TCP service, right? SSH is a secure shell. But that is a management, right? So that management, all management tasks will run by MGD, management
MGD.
daemon.
Oh,
Yeah,
so MGD is a daemon there. Okay.
yes, MGD is a daemon which will handle all SSH and console
Service.
sessions.
Okay.
Yeah,
Okay.
all SSH and console sessions.
Okay. And to see that what all daemons we have to run that shows processes or something, right?
Yes. Show system process.
Okay.
Here you will see show system process. Extensive. If you want extensive output, you can give extensive. Here, one second. Show system process extensive. Actually, you have to execute this command in operational mode only. Okay. Yeah. Here it is the MGD, right? This will take care of all management CLIs, either SSH or telnet or console. Yeah.
Suppose just a out of box question. Suppose if we are looking to have SNMP enabled, we have to enable SNMP daemon initially.
Yeah.
Okay.
Yeah. For if you are using any SNMP service, right, you will have SNMP daemon. Okay. If you see here, you have SNMP. If you want to check while troubleshooting, right, if you want to check any specific output, right, match with SNMP. You will see SNMP. For cause, you will have separate cause. Okay. Class of service. Have separate daemons. For routing protocols, you have RPD. For management things, right, you have MGD. See, you have MGD and DCD. DCD is responsible for if you assign any IP addresses on interface, right, configuration on interfaces, that will take care by DCD. Yeah, this is the thing. So you can start practicing it. Okay, whatever we have discussed so far. Okay, go through the document and execute step by step. Okay, assigning the IP addresses, on the interfaces, I will mention here, and theoretical also, if you want to learn, right, I have provided everything, much more information here. Okay, you can go through it. I will provide to the team, and they will they will give access to you. You can get the files from management team. Okay,
and tomorrow we have class or what?
yeah, we will update you.
Okay.
Yeah, tomorrow is a class, Ramesh.
Okay, so we will continue tomorrow. So you can do lab today. If you stuck anywhere, right, we can continue tomorrow. I will explain you tomorrow, but please do lab today only. Okay, take some time, take rest some time and do lab. So access will be provided by our team. Okay, tomorrow we'll continue other things and start doing dynamic routing protocols and static and default routing protocols. Okay, fine. So far, if you have any queries, please let me know. Anyone, if you have any queries, you can Someone is asking something. Yeah. Juniper OS is developed based on the Unix, FreeBSD Unix. Okay. You will see some similarities. Okay. In Unix also, you will have management daemon and different daemons, right? Similarly, you will see here as well, because this is developed based on FreeBSD Unix. Okay. It's an open source software, right? Based on that, they have developed. So you can find some similarities. Yeah. See, physical daemon in the sense, daemons are there in routing engine. I told you, right? All the daemons are located in routing engine. Each and every daemon have their own responsibilities for RPD, PFED. Yeah, each and every daemon have the chipset internally. They have chipsets, ASICs, application specific integrated circuits. So physically, chipsets are there, but you cannot see physically. That will be inbuilt on the board, routing engine, motherboard. Okay. Fine. Any questions so far?
Thanks, Ramesh. So we'll continue tomorrow.
Sure. Yeah, we'll continue tomorrow. Thank you, guys. Have a nice day. Yeah. Bye bye.